And section 2.6 continues. We're going to solve more inequalities, but this time they're polynomial and rational inequalities. You guys know rational means ratio, means fractions. Okay, but sometimes students get tripped up with the word polynomial. Well, it's like a rational function, except for you don't have a fraction. Think about what's in the top and bottom of a rational function. That's just a polynomial. So the directions are solve the inequality and graph the solution on the real number line. This is a polynomial right here. It's not a fraction. It just is made up of a mixture of x's with exponents, etc. But notice the difference between this and the first video, or the first lesson in this section, is that now we have a quadratic term. I don't know if you noticed, but in the first video we had only linear terms. Like if I were to cover this part up, we only had this situation. So it gets a little more complicated. Alright, so what's our strategy for solving this polynomial inequality? Well, you might not see it right away, but right here, this is a trinomial square. It factors into a binomial square. I could put x here and 2 here. It's positive. If I were to FOIL or box this, I would get back to the resulting trinomial. Alright, why would we want to look for something like that to do with this? Because I'm going to write the problem down again. We're going to be able to do something that we're familiar with. Alright, let's hope that I can change colors without too much trouble. Okay, I have a binomial square, so I'm going to bring in the square root. When I bring in the square root and I simplify, what we've been doing is bringing out the absolute value of x plus 2, because this is an even power, an even root, not odd. I wouldn't have absolute value if it was an odd power and an odd root, but I do on the 2, 4, 6, 8, the even numbers. Greater than, simplify 3. Alright, well, we're back to what we did in the second lesson. We're back to a inequality with absolute value. Well, it's isolated. We need to remember that with greater than, when we remove the absolute value, we keep the greater than or equal to 3. The greater than means or. We're going to have x plus 2, but this time we'll reverse the symbol, and it has to be less than or equal to negative 3. So let's solve each resulting inequality. Graphing our solution. In order, we have negative 5 and 1, both closed circles. Go back. Do we connect or do we go on opposite ends? Well, x is greater than or equal to 1, and x must be a number less than or equal to negative 5. So if I choose any one of those numbers in either of these sets, don't choose a number between negative 5 and 1 and put it back into the original problem, the computations over here would give us a number bigger than or equal to 9. Okay, so let's look at another one. Well, that's a nice one. They already factored it for you. So we're going to proceed like we did in example 1. I don't like to crowd the original problem. I'd like to look at it, so I'm going to write it down again. It doesn't take long. I'm going to bring in the square root. It's an even root. I know I'm going to bring out an absolute value. Notice the symbol is less than, whereas that one was greater than. We just have to connect back to that previous lesson. If it's less than, we're going to put x plus 2 in between negative 5 and positive 5. So just write without the absolute value, and then over here on the left, put in greater than negative 5. So we're solving the resulting equation. Subtract 2 from both numbers. Graphing on a number line, x has to fall between negative 7 and 3. Open circles, connect in between. The polynomial inequalities are pretty simple if you guys can factor if need be and then bring in the square root and then return to an absolute value inequality. It's going to be a little more challenging when we do the rational inequalities, which that's upcoming. Okay, and it looks like we have 3 examples of that. All right, there's a set of steps to use to solve these rational inequalities. So I think what I'm going to do is I'm going to record each of those steps over here as we go through them. That way you'll have a recording in your notes, so when we get to a later lesson, like a month down the road, and you forget how to solve these, and we need to remember, you can look at your notes and you have a guideline for solving rational inequalities. All right, so the first thing we're going to do is I'm going to come over here and put a note to ourselves. If our rational inequality isn't already in general form, well, it does already have a 0 on one side of the inequality. That's 0 on one side. Okay, we also need to rewrite this as a single fraction. Rewriting as a single fraction, another way to say, let's get a common denominator. Well, x is going to be our common denominator, so all I'm going to have to do is multiply this term by x over x. Rewrite as a single fraction, so I know x is my common denominator. 2 is good, minus, and then I have over here 2x squared as a result of multiplying the numerator together. See, there's that minus. So that was our first step. Let's write it in general form. Get a common denominator if you need to. Okay, so that's step 1. Step 2. All right, let's locate the key numbers. You might be thinking, well, what are key numbers? Well, here we go. That would be the zeros of the numerator and denominator. All right, well, when I look over here, I can see the denominator is easy. The key number for the denominator, so record key numbers, x equals 0. All right, let's look at the numerator. Okay, what are the key numbers of the numerator, which would require us maybe to come over here and do some side work. Okay, to get the key numbers of the numerator, I'm going to set the numerator equal to 0 also. So you're looking for the zeros of the numerator and denominator. I know when I factor out 2, and I continue factoring, if you want, I'm going to have 1 minus x and 1 plus x. Set each factor equal to 0, and I think we can all do that. So the result is x is 1 and x is negative 1. I might otherwise put those in order, but not a big deal right now. So I'm going to come over here. Positive, negative 1. So we wrote in general form, we got a common denominator, 0 on one side, locate the key numbers. That means we had to set the numerator and denominator equal to 0, get those key numbers. Okay, next thing, we're going to create a number line with these key numbers. Okay, so we're ready to organize our work. All right, so in order, negative 1, 0, and 1. All right, open circle or closed circle above these zeros. Well, okay, that's kind of what we're thinking. However, okay, at this point, okay, it's really not about the inequality, whether we put open or closed circles above these key numbers. Okay, it's about what we get out from the problem as a result of plugging in negative 1, 0, and 1. For example, if I plugged in negative 1 to the numerator, I'm going to get 0, but in the denominator I'm going to have negative 1. So 0 over negative 1 is just 0. So it's not like it's part of the inequality. What we record above the key numbers are what happens when we plug these key numbers into the original problem. For example, plug 0 in. you're going to get 2 minus 2, which is 0 over 0. Well, that's undefined. Undefined. You can't divide by 0. Well, when you plug 1 in, it's okay to have a 1 down here, but the top's going to be 0, so the result is 0 in the numerator. I hope that's not too confusing for you, because I know what we were doing before. We were looking at the inequality to determine if we wanted an open or closed circle. Okay, so we created a number line with the key numbers, and we documented above it whether those key numbers gave us 0 or undefined. Okay, step 4. We're going to test some x values that fall in the intervals created by our key numbers. Test points are x values. Maybe x values would be better. In the intervals created by the key numbers. Okay, what does that mean? Well, come over here and let's look at this set of values that come up from negative infinity to negative 1. It doesn't matter what number you choose, just choose any one of those numbers. Say, for example, negative 2. Okay, well, how do I test it? I chose it. Well, plug negative 2 up here, and for x here and here. So remember, right here, that when you plug in negative 2, our test value from here, we're going to get a negative denominator. Right, if I plug negative 2 in here and square it, I get 4, but 4 times 2 is 8. 2 minus 8 is a negative number, so this is negative over negative. The quotient is positive, so that's what I'm recording above all the numbers from negative infinity up to that first key point. All right, just bear with me. Okay, so let's do another test value. Well, negative half falls between negative 1 and 0, so let's plug negative half in for x here and here. Well, the denominator is going to be negative. All I care about is, am I getting a positive or negative number as a result of plugging in negative half? So denominator is negative. Negative 1/2 squared is positive 1/4. 2 times 1/4 is 2/4 or a half. 2 minus a half is a positive number. Positive divided by negative is negative, so the result is that any number that falls in the interval between negative 1 and 0 would result in getting a negative number. Bear with me. Now plug in positive half, because that's a good number. I could have plugged in a third, a fourth, any number that falls in this interval. I'm just hoping that 1/2 isn't too cumbersome. So plug in a half, positive denominator, positive half, same result as last time. We're getting a positive numerator. So the result is any number between 0 and 1 when replaced in for x would result in a positive number. Plug in a number greater than 1, like 2, positive denominator, negative numerator, the result is negative. That's a lot. All right, now based on our number line, we're going to choose the correct sign for the inequality or for the problem. Meaning, let's choose positive or negative based upon the inequality. That's where that inequality symbol becomes important for this problem. All right, well, going back to the original problem, we want less than. We want negative numbers. So as you scan from left to right, negative 1 to 0 would produce negative values. Any number greater than 1 when replaced into the original problem would also give us a negative solution, so that would be 1 to infinity. All right, so we sketched all our solutions on the real number line, but we're also taking and jumping off of that and saying, you know what, using interval notation, okay, this is the solution for that set. So looking back, solving rational inequalities. Okay, we don't get rid of the fractions. We write in general form, getting a common denominator with 0 on one side. We did that here. We located the key numbers by getting the zeros of the denominator and the numerator with some help over here. Okay, we put those on the number line. We chose particular values in those sections, okay, created by those test values to see if the result in this problem was positive or negative, and then we went back and looked at our inequality symbol to see which ones we wanted, the positive or negative solutions. So at this point, I'm going to do 2 more examples, but it'll be in the next video.